Hello and welcome everyone to the Data and AI Forum virtual event. We're really excited that you've joined us today. I want to start with a story. So I started my career as a data scientist, and what you saw in the previous session, what we are able to do with Auto AI today is something that I took 2 months on to deliver. And I'm just fascinated how easy my job would have been and how much more I would have accomplished if I had such great capabilities. And of course, right, the whole investments that IBM is making in advancing or making it simple for you to build the information architecture required for AI. But in spite of this, we are still not seeing a huge adoption of AI in the industry. We're seeing surveys that range between 14% to 20% adoption of AI. This is in spite of the fact that AI is currently the top priorities for businesses in India. Almost all surveys are indicating that companies today and the CEOs today are looking at AI as a source of competitive advantage. And it gets us wondering why that is happening. And we asked our clients why they're able to build such great models, but they're still not able to invest or they're not able to deploy those models. And the survey results were interesting. So 60% of the companies that we surveyed, they came back that they see regulatory constraints as a key barrier for implementing AI. Now, they're seeing that they need to invest in very expensive data scientists who are able to manage their model well, and without that, they don't really trust the model. And then, of course, right, like the governments are stepping in. You see, right, like if you're giving a decision-making authority to an AI model, you want to make sure, or the governments want to make sure that the model is compliant and is following the regulations required in the law. And also, it is very difficult to track and measure business success in production. Like you created a model, but how is it performing in real life? That sometimes is very different. So that was one part. And the second big challenge that we see is technical skills. So 63% of the clients we interviewed, they cite technical skills or lack of technical skills as a key inhibitor to adopt AI. And this session today, we are going to show you a technology that no other company has today, a fascinating piece of development done by IBM Research Lab that you can use or start to use today, either the open source versions or what's an open scale or as part of Cloud Pak for Data that addresses this key gap from getting you or helping you build the AI models and taking them into production and scaling the AI with trust and transparency. Now, you must be wondering, like maybe in your particular company, like you're thinking, okay, AI regulation is new, it does not impact you. Let me tell you, that's not the case anymore. We've seen multiple examples where companies have been fined, like a leading bank was fined $175 million for charging higher fees and interest rate to more than 30,000 minority buyers, and a large credit card company was fined $75 million for selling products to Spanish-speaking customers for a much higher interest rate compared to others in US. So that's happening around, and very soon we will see in India that the regulation is going to catch up, and you want to make sure that the models that you have in production do not break any laws. And guess what? It's not necessary that the reason that your models are not compliant is because of intent. Sometimes, and more often than not, the real root cause of why the models are not compliant or they're not behaving in an ethical way are because sometimes the training data that we have given or used is not good. Let's take an example, right? Like if, say, hypothetically, I'm a bank and I'm building a model for creating or giving or analyzing who do we give loans to, and this is a high ticket home purchase. Let's assume that's worth more than 30 million Indian rupees. And if I take historical data of last 50 years, I would see that most of my purchasers were male, because traditionally we have seen in India that males have dominated property purchases, the women are starting to work. But is that model that we built for woman from that data would be relevant for them? The answer is no, because the data that we have, and this is not by design, it is just the fact that last 50 years, we have a much higher data of males applying for big ticket home loan purchases than female, and that introduces a bias in the model for female or potential female loan applicants. So they're there, and let's look at how does OpenScale address these problems. Now, the first thing OpenScale does is it helps align model performance with business outcomes. Like if you are thinking of launching AI model, this is a no-brainer, right? Like you want to make sure you measure this effectively, and then you want to ensure that models that you've created are resilient to changing situations. Like if you're using AI to impact revenue, identify problems with business model, or transform operations, you have to track changes in business inputs. Models need to keep up with it much faster than manual review and retrain recommendations. And finally, when you see or encounter regulations, you want to be able to prove that the AI models that we've created, they are compliant with the regulations. So sometimes it's not just about they having the right intent or the following the law, but also being able to prove that. So OpenScale makes it really simple to do these things, which are very valuable as you look to accelerate your AI adoption in the enterprise. Now, OpenScale plays a critical role, and I'm going to go back to our AI lifecycle. So OpenScale is critical. Like once you've built that model, you've used Watson Auto AI and Watson Studio, you have used Watson Knowledge Catalog for organizing and governing data, you're using Watson Machine Learning to deploy and run. OpenScale is at the end. We're using OpenScale for operating trusted AI. And let's look at it. What are the critical capabilities that organizations do not have today? They do not have clarity and visibility into how organizations' AI is built, run, and managed in production deployments. And Watson OpenScale will measure on operations around AI with trust and transparency, leveraging the most commonly used frameworks and runtime. Like let's look at it, right? Like many of us are using machine learning libraries or open source deep learning libraries to build our AI models. Are you able to know, like say for example, if you're using scikit-learn or XGBoost or TensorFlow, are you able to know what is inside that model or what is inside, or what features is XGBoost prioritizing versus how is TensorFlow building the model? So OpenScale is able to work with leading and popular open source machine learning libraries, and is able to give you or make sure that the black box does not exist. Now, let me talk about core OpenScale functionality. How does OpenScale really work? So you would see that we are going to measure, like you have historical data, you do perturbation analysis, then you have variance over subset of the data, then you build a risk model. And then what OpenScale does is it would sit on the product in the runtime, it would internally detect bias, and it would tell you, is your model fair or is your model unfair? Okay. Then finally, it's not just the OpenScale that we have to solve this problem today. We have 3 key products, and 2 of them we're pleased to announce are available to you in open source today. We have open sourced them. You can start using them without paying anything to IBM. So the open source tool is AI Fairness 360. What it does is it tries to fix problem in data selection. Then it also does intercept and fix algorithm or in algorithm design. And then we have Watson OpenScale, which does online post-processing, and it intercepts and fixes features once your model is in production. So between AI Fairness 360 and Watson OpenScale, we truly believe that we have the end-to-end safeguards that you need to make sure your model is trusted, is explainable, does not have biases, and it works very well with the regulations. And then let's look at it. What does the new or key features that we are announcing today. So what the new feature that we're announcing is Drift Monitor. Now, if you see, you build your model on training data, and it's not necessarily the same as production data. So in many cases, what we have seen is your model is really accurate when it is built, and then when it comes into production, the accuracy starts to decline, and this is a big cause of concern. And in fact, like any data science customer that I've spoken to, we have seen this happening in almost all scenarios. And this is a big challenge that we are solving today as a new feature in OpenScale.
Before an AI model is put into production, it must prove it can make accurate predictions on test data, a subset of its training data. However, over time, production data can begin to look different than training data, causing the model to start making less accurate predictions. This is called drift. IBM Watson OpenScale monitors a model's accuracy on production data and compares it to accuracy on its training data. When the difference in accuracy exceeds a chosen threshold, OpenScale generates an alert. Watson OpenScale reveals which transactions caused drift and identifies the top transaction features responsible. For instance, 25% of the transactions causing drift in this loan approval model were problematic because of loan duration, current residence duration, existing credits count, checking status, and property ownership. The transactions causing drift can be sent for manual labeling and used to retrain the model so that its predictive accuracy does not drop at runtime. Watson OpenScale not only helps identify drift, but also highlights its root cause and provides transactions which can be turned into training data useful in fixing drift. It gives you the insight you need to ensure that your models will consistently deliver the results you want over time. For instance, the retrained version of the model, but based on the recommendations made by Watson OpenScale, started making accurate recommendations, alleviating the drift. This is just one of the ways that Watson OpenScale helps you ensure your models are fair, explainable, and compliant, wherever your model was built or is running. Learn more and get started for free with these links.
So now I also want to talk about the fact that it's not necessary that your data is in one place, right? So you have data behind your firewall, and you have data in cloud, and in many cases you're using multiple third-party data as well. So you need like a trusted component that would work across where your data is or where you're producing your model. So we are announcing Watson OpenScale being available as part of Cloud Pak for Data, which is our primary platform for building and consuming AI. Then you can consume Watson OpenScale as in public cloud as part of IBM public cloud infrastructure. And then we're also making Watson OpenScale available at third-party cloud providers. And with that, we believe we are truly multi-cloud. So you will get the same trust, transparency, and you would be able to get the regulatory compliance across for your AI models, irrespective of where your AI model is. Now, and it's not just that. We do have a bunch of additional features and functionalities that we're developing that you would be able to access in real time very soon. So we see that validation of AI models to augment governance and manage risk, it does not exist today, especially when we look at some of the critical or governed sectors. We have done an MVP release on financial services sector. In many cases, processes rely on regular interaction between validator and model developer. And in many cases, we see current systems focus more on documentation and governance aspects of the model validation. And traditional statistical models are deterministic in nature or simpler to interpret and explain. And what we will be launching very soon with Watson OpenScale is that we would be able to enable a validator to define and configure testing of pre-production models, validate pre-production models by running configured tests and generating actionable reports or outcomes, facilitating transition to production, maintaining configured monitors and alerts, and finally synchronizing results with governance, risk, and compliance solutions like open pages. Now, as we say, the proof of the pudding is in the eating. So I want to give you a demo on how OpenScale really does.
This is the first in a series of videos about Watson OpenScale, IBM's solution for providing trust and transparency for your machine learning models. Today, I'd like to focus on OpenScale's explainability feature, which gives you the ability to look at individual transactions and determine exactly which feature values are influencing your model's predictions. OpenScale can provide this information for both simple models such as decision trees, as well as for complex neural networks. We'll examine predictions made by a model that attempts to predict the risk of a credit application using features such as the amount and duration of the loan, the credit history, salary, and employment status of the applicant, and other information. The model outputs a prediction of either risk or no risk, as well as a prediction probability that represents how confident the model is in its decision. To explain a transaction, you can select one from the prediction log table itself, or from the transaction tables available from the various monitors. OpenScale summarizes its findings on the Explain a Transaction screen shown here. In the upper left, you can see the information on the deployment and model that made the prediction. In the lower section of the screen, OpenScale provides a brief description of the prediction and the features that had the most influence on the outcome. For this particular prediction, OpenScale deemed the application to be risky, but with only 62% confidence. The loan duration, age of the applicant, and the applicant's employment duration were the primary factors leading to this decision, summarized in the table to the right. Scrolling down, we can get a more complete picture of how the different feature values affected the outcome. The values on the right helped lead to the risk prediction. Those on the left influenced the model towards a no-risk prediction, lowering the model's confidence in the risk outcome. The values in this table were generated by the industry-standard open-source LIME algorithm, which performs thousands or tens of thousands of perturbations on the data, slightly altering each feature value and sending the new data to the model. The impact on the resulting prediction and probability allows OpenScale to assign weights to each value, representing how important that value is to the model's final prediction. The percentages represent the weight each feature has on the prediction, so adding up the percentages for features contributing to risk and features contributing to no risk will equal 100%. Not all feature values are shown here. Those whose influence on the prediction fall below a particular threshold are omitted, which is why these numbers do not add up to 100%. Additionally, OpenScale offers more insight into the prediction with IBM's contrastive explanation technology. If we expand the section at the top of the screen, we can see just how much we can alter the feature values to affect the prediction. The section on the left, minimum changes for no risk outcome or pertinent negative, represents the minimum set of changes in feature values to generate a different prediction, listed in order of importance. What needs to change about the application for it to not be considered risky? Clearly, not all of the values represent things the applicant can change. Very few people are willing to reduce their number of dependents or change their gender to influence their credit score. However, if the bank chooses to expose this data to their customers, it does provide useful information on ways to get a better evaluation, such as more money in available savings accounts, a shorter loan duration, or a smaller loan amount. This data is also useful for our data scientists evaluating the features which affect our model, which can be difficult to gather for complex neural networks or for models with thousands of features. The section on the right, maximum changes allowed for the same outcome, or pertinent positive, represents the maximum possible change while maintaining the same prediction, again listed in order of importance. Here we can see the tolerance our prediction has for changes in the data. How much can the application be altered and still be considered risky? The explanation feature can be accessed via the OpenScale UI. However, it is also available to your application developers via OpenScale's JavaScript and Python APIs. This allows you to infuse this information into your business applications or provide it to your data scientists. Here we can see how the explanations are accessed for analysis via Python Notebook in Watson Studio. And here is an example application that uses OpenScale's JavaScript APIs to provide detailed explanations to adjusters investigating an auto insurance claim. The APIs return the data in JSON format, which the developers can integrate into their front-end application to highlight possible areas of concern for the adjusters. As you have seen, Watson OpenScale provides a wealth of explanation information for individual model predictions from both open source and proprietary technology without having to add any steps to your data flow. Whether you're using explanations as part of an in-depth model audit, providing information to your data science teams to help them evaluate your models, or surfacing relevant data to customers via business applications, IBM Watson OpenScale can help. For more info, go to ibm.com/demos today. Today, I'd like to focus on OpenScale's fairness monitoring feature, which gives you the ability to monitor your machine learning models for unfair bias at runtime, ensuring that the models are making fair decisions and comply with regulatory guidelines or business standards. We'll look at configuring the monitor through OpenScale's user interface and then how to read the charts OpenScale provides. First, we'll talk about how to configure the fairness monitor via the user interface. The monitor can also be fully configured using OpenScale's Python client. Having uploaded our training data and sent some records to the model for scoring, we have provided OpenScale with information on how our model receives and returns data. On this screen, we will specify our positive and negative outcomes by clicking and dragging them to the relevant areas of the screen. This is a binary classification model, so we only have two outcomes. Multi-class classification models would allow us to assign multiple values as positive or negative. Regression models would allow us to specify positive and negative ranges for outcomes. Next, we'll select the features we want to monitor for fairness. Though this will often be a regulated feature such as age or gender, we can select any feature of the model. This can also be updated at any time if we'd like to go back and add a feature for monitoring at a later date. In this case, OpenScale has suggested we monitor age and sex. For each feature, we need to set reference groups and monitored groups. The monitored group will be compared with the reference group when OpenScale computes fairness. For the sex feature, we will monitor females for unfair bias. We will then need to set a threshold for acceptable fairness. If the rating drops below this threshold, we'll receive an alert on our Insights dashboard. The age feature is represented by an integer, so we will need to input a range of numbers to create a reference and monitored group. Here, we will monitor younger customers for unfair bias, then set a fairness threshold for this feature. Once again, these groups, ranges, and thresholds can be updated at any time. Finally, we need to set a minimum sample size for the monitor. The monitor runs hourly and will always use at least this many transactions to create a fairness score. If the model makes more than this number of predictions in 1 hour, it will calculate the fairness for all the predictions made during that hour. Now that we've configured the fairness monitor and had our model make some predictions, let's take a look at some of the output. We'll use the OpenScale user interface, but all of the information contained in the screens and charts we're about to see is also available from OpenScale's Python client and REST APIs. In the left panel, we can see the two features we configured for fairness monitoring. In the main portion of the screen, we can see the model's performance over a specified time window. In this case, we're looking at hourly fairness scores for our 18 to 25 age demographic from the past week, and how those compare to the alert threshold we set. Clicking on the sex feature switches the view to show us how our model performs with this feature, and we can see that it regularly drops below the threshold. We can now click on the chart to drill down into the data and to get a better idea of what the model is doing. This screen shows us the fairness rating for a specific time window. At the top, we see selectors for different available statistics. OpenScale calculates the fairness score using both actual payload data scored by the model as well as the perturbed data. If the prediction probability from the model is close to 50%, OpenScale will flip the monitored variable, in this case male to female or female to male, and send the record to the model again to see if this affects the outcome. These extra predictions allow OpenScale to gain a more accurate picture of how the model is treating our reference group, which is reflected in the payload versus perturbed section. Our fairness score for the model during this time period will be the percentage of favorable outcomes for the reference group, 63, divided by the percentage of favorable outcomes for the monitor group, 74. Using the radio button at the top of the screen, we can also see the breakdown of the actual payload data, as well as the training data. From here, we see a comparatively small amount of training data for females, which may be the source of some of our unfair bias. We can click on the debias section to see OpenScale's automated debias capabilities. OpenScale has created and trained a model that will predict when our production model will make an unfairly biased prediction. If we choose to use the debiased endpoint to make predictions, OpenScale will flip the monitored variable from male to female or female to male before sending it to the model, and then return the unbiased prediction. This screen shows how using the debiased endpoint will affect fairness for our other features, allowing us to choose whether or not to use the debiased model. Finally, we can click on the View Transactions button to see the individual predictions made by our model during the time window, and use OpenScale's explainability features to examine them in greater detail. As you have seen, Watson OpenScale provides a highly configurable, easy-to-use runtime fairness monitor for your production models. Whether you're operating in a highly regulated industry with strict fairness standards or implementing your own guidelines, IBM Watson OpenScale allows you to trust that your models are making fair predictions.
As you saw, Watson OpenScale today delivers industry's best capabilities and is the perfect product that can help you get started and accelerate your AI journey where your AI models are trusted, transparent, and bias-free. And these capabilities come in the base edition of Cloud Pak for Data, which is industry's best platform for you to get started on your AI journey. And I would highly recommend you try Cloud Pak for Data experiences on IBM.com. And also, if you are an AI practitioner, you should definitely try and explore AI Fairness 360, which is available as open source, free of charge. And if you like it, you can always start using Watson OpenScale as well, or as part of Cloud Pak for Data. In addition to that, I have some exciting news for you to share. We're building a community of AI practitioners and decision makers where we already have 120,000 members, the 12 communities, 300 local groups. We would be loading all the presentations and material from Data and AI Forum there. You can view the webinars, blogs, ask me anything, and a lot more discussions at the community. And I would highly recommend that you sign up. And I look forward to engaging and interacting with you on the community. And we will be coming to Mumbai very, very soon in May. And I look forward to meet you. In the meanwhile, if you want to get started on your AI journey, I would highly recommend you sign up for expert advice. And I look forward to talk to you on that. So thank you. Thank you for joining and look forward to that.